So welcome everyone, and it's a great pleasure to be here this evening. That's on behalf of myself and the four co-presenters today. We are going to be talking about the Centre for Personalised Medicine and its role in St Anne's. Many of you will know that the Centre for Personalised Medicine is a partnership between the University of Oxford's Wellcome Trust Centre for Human Genetics and St Anne's College in Oxford. It is a communication, engagement and research vehicle for students, academics, clinicians and the public to explore the benefits and challenges of personalised medicine. And since September last year, I've been the director of this. You can see here the steering group and secretariat, and outlined are me and the four junior research fellows that will each tell you a little bit about their role within the CPM. I'll come to that in a minute. So just a little bit about my background. So I trained in medicine, and after doing my higher medical training, I did a DPhil in Oxford, identifying genetic factors in diabetes. And then I've spent the last 20 years or so researching the ethical, legal and societal issues at that interface. So the issues in translating laboratory findings into clinical practice. And my research group, the Clinical Ethics, Law and Society, or the CELS group, started in Southampton, the University of Southampton. It retains a footprint there, but now also sits within the Wellcome Trust Centre for Human Genetics in Oxford. And that research group fits so perfectly within the mission statement of the CPM that although I've only been in post for 5 months or so, it really feels like I've come home. And that is very much helped by a completely awesome team of junior research fellows that you'll hear from in a minute. You will, as St Anne's alumni, know that the term junior is very misplaced when it comes to JRFs, because each of them does so much more than that term suggests, and they each have their own research and a fantastic portfolio of outreach events under the umbrella of the Centre for Personalised Medicine that they'll give you a little brief overview of in a minute. So I thought I'd just start by trying to define the term personalised medicine, and I thought I'd start with my definition because there really are many different definitions around, and it's one of those terms that people that speaks to people, but often in a slightly different way. So to some, the term means our relatively newfound ability to hold a lens to our entire genetic code and try and see what diseases someone might have or be at risk of, or what treatments they might particularly benefit from because of variation in their genetic code. That's a very common understanding of the term. But of course, this is a little bit oversimplistic because it's diseases or treatments simply don't leap out from the 3 billion letters in our genetic code in this way. And many others, including myself, would argue that medicine has to some extent always been personalised, or at least as personalised as the tools available to us. So there were, when the term was first coined 10, 15 years ago in relation to technological advances, there was also very much a reaction of, well, nothing new to see here. This is just a technological advance, but no real change in the practice of medicine. And I think a different term, again, reflected by the cartoon on the right, is that in a world where the amount of data gathered about a person is still exploding exponentially, as are the technological approaches to that data. We need to recognize that the data alone won't improve medicine, but that medicine will only be successful if we personalize the care from that data as best as we can, and that we use the context of the patient or the population that we're looking at as best we can, rather than simply thinking a readout of, for example, the genetic code will do that. And so I think that personalized medicine in that context means that we have a responsibility to do something with the masses of data that we are collecting, that technology can now easily collect, but we have a responsibility to interpret it in particular ways. And increasing that also means not just collecting it and deciding what we'll do with it later, but thinking about collecting it in a responsible way that recognizes diversity in our population, but also increasingly thinking about sustainability issues and the carbon footprint of that sort of data collection, and therefore not just collecting it for the sake of it, but thinking about what we might use it for. And we did, just as I joined the CPM, we did a short video of what the Centre for Personalised Medicine does for a large American conference on genetics. I'm going to try and play you this. It's a 2-minute video. Medicine's always been personalised to some extent, but over the last 5 to 10 years, there's been a massive explosion in the amount of data that we can gather about people. That data explosion extends from our Fitbit trackers to kits we buy over the counter, to being able to analyse our genetic code quickly and cheaply. And all those together really increase the opportunity to target interventions and medicines in a much better way. But in order to do so effectively, we really need to also pay attention to the ethical, legal and societal aspects that are involved in implementing those exciting advances in practice.
The Oxford Centre for Personalised Medicine was formed in 2013 to engage and communicate with scientists, students and wider publics, and to address a widening gap between the advancing science and the application and practice of personalised medicine. Multidisciplinarity is vital to the CPM mission. Biomedical and social sciences are represented within the team and steering group. We've engaged with and held events involving researchers in many different fields, including law, economics, bioethics, demography and palliative care.
We recently hosted Jennifer Doudna, who won the Nobel Prize for her work on CRISPR, to talk to us about this. We've also hosted COVID vaccine developers, epidemiologists, ethicists, genomics scientists, and genetic counsellors, and many, many more besides.
The Centre have also been working together with school children, inspiring an early interest in science and medicine and what that's going to look like in the future.
We are always seeking innovative ways to engage.
And expertise to look at the whole picture about personalising medicine. Just to give you a bit of a summary that you can also get from the website are some of the events that have been run by the Centre for Personalised Medicine over the last couple of years, a really wide-ranging set of talks and meetings that are all largely thanks to the pandemic now recorded and available online to look at any time. And we've also been involved in creating some animations to explain some of the issues facing Centre for Personalised Medicine. We've got 2 at the moment, but are planning more. One is on polygenic risk scores, which is a new way, or newish way, of being able to look at variation in throughout the genetic code, where each variation on its own doesn't do very much in terms of risk, but whereas a composite risk score of many thousands of different variations in the code might tell you something more about the risk, particularly of common diseases. And we've also got an animation about how we think that in some areas the health service and research could be better aligned, such that the two feed each other in a learning healthcare environment, rather than the increasingly separate silos that we sometimes see. And recently, Dr. Katherine Wood, who you'll hear from in a minute, has started a really exciting series of vlogs, so short films on the CPM website. We're releasing them every other week, I think. We've had 2 now, and I would urge you to look at those because they're really fascinating insights into what senior people in the field, and so Nina's a sociologist, and Andrew Wilkie is a clinical geneticist, and their views on what personalised medicine means and how their research has influenced that. And we've also been lucky to be involved in various public engagement exercises. This was one that we held together with Welcome to a Centre for Ethics and Humanities last November in Museum of Art in Oxford, where Vivian Parry, who's a broadcaster, interviewed myself, Professor Michael Parker from Ethox in Oxford, and a patient, CEO of a patient organisation, Sarah Wynne, about the ethical issues in offering whole genome sequencing as a newborn screen. And we've also influenced policy in a variety of ways. I've flashed up a load of different ways in which my research group has been involved in influencing policy. Some of these are obviously from before my time at the CPM, but as I say, they're very much aligned with the mission statement of the CPM. So with that brief and technologically flawed intro, I'm going to hand over to the Junior Research Fellows to say a bit about their research, round up at the end of that and open up for a discussion where hopefully I will be able to see who's asking the questions. So firstly, Dr. Porrig Dixon will speak, followed by Dr. Nikki Whiffin, Dr. Rachel Horton, and Dr. Katherine Wood to finish. So Porrig, are you there?
Here, thank you, Annika.
Here's your first slide.
Great. Thank you very much, and good evening, everyone. I'll just say a little bit about myself and my association with St. Anne's before talking a little bit about some of the research I do in my day job and how that feeds into my role as a JRF in the CPM at St. Anne's. So I work in the Department of Primary Care, which is across the road from St. Anne's and Woodstock Road. So if you're in St. Anne's more than about 20 years ago, the building that was the Radcliffe Infirmary is now the Primary Care Department. And it's now quite a different structure and set of activities that are going on there. And what I spend my time doing is I work as a health economist, and I'm looking at some of the challenges and opportunities for society from using genetic data and using more genetic data and using it in different ways from the perspective of health economics. So there are 2 broad areas where I'm doing research at the moment. One is about the opportunities for using genetic data to improve causal inference. So that's improving our understanding of the ultimate causes of disease, as well as the consequences of disease, and also the prediction of health economic outcomes. So that might be things like hospital costs, how often you see your GP. And a big opportunity at the moment is using a particular type of genetic data, which Annika mentioned, called polygenic risk scores, to screen healthy people for common diseases. So in terms of causal inference, this is some work that's trying to understand how we could improve the evidence that's available for people making decisions about the type of care that's provided to us in the NHS, the type of drugs, the type of services, and the other type of care that we might receive. So generally, this is a very difficult thing to do. So for example, if you're interested in, for example, the effect of prostate cancer on healthcare costs or the quality of life of people with healthcare prostate cancer. It's difficult to study that because many variables both influence the fact that someone might have prostate cancer and the level of healthcare costs, the general quality of life they have. And that's very difficult to disentangle. A traditional way of disentangling those effects is to run a randomized controlled trial. But we can't randomize people to have disease. So we need to find a different way of answering those questions. And I'm using something called Mendelian randomization, which is using bits of the genetic code that might predict disease status, or might predict a particular trait like how much you weigh, or might predict a particular behavior like smoking. And by assessing those indirect relationships, we can actually create new estimates of how disease or behaviors or traits affect particular types of outcome. And in turn, we can use that to support robust decision-making. So for example, if we were interested in reducing the incidence of lung cancer, we might be interested in how much it would cost for a new advertising campaign to reduce smoking or other types of intervention. And this type of analysis helps us answer those types of questions in a way that we can't really do with traditional ways of generating that evidence. And another related branch to this is about predicting the future. So not understanding why relationships are what they are, but predicting what might happen in the future. So one thing we might do is predict how much care we might receive in the future from people's genetic code. And that might be interesting because it might help us find people who are currently well, but might be sick in the future. It might find bits of the genetic code that dispose people to attend hospital or to have expensive care. And there are a few issues with this. One is that it might be useful to do that, but it also poses a lot of challenges. And this lady on the right is a 77-year-old who lived in Michigan in the US. And her mother died from Alzheimer's disease. And she observed firsthand what that did to her health, but also what it did to her financially. And she needed very long-term and very expensive care. So this lady decided, well, maybe I should find out my risk of Alzheimer's disease. So she sent off a direct-to-consumer kit to see if she had 2 copies of a particular gene, the ApoE4 gene, and bad copies of that gene increase the risk of Alzheimer's disease drastically relative to the general population. So if you have 2 copies of those of that gene and you have a family history of Alzheimer's, then you are at higher risk of developing Alzheimer's. So she took that test. She found out she did have the ApoE4 variant that increased the risk of Alzheimer's disease. So she took out long-term care insurance. And under US law, she wasn't obliged to tell anyone that she'd taken that test. So her insurer doesn't know that she's at much higher risk of Alzheimer's disease. And that, of course, opens a whole Pandora's box of whether it's fair for people not to disclose that information, whether it's even sustainable for insurance to exist if no one is obliged to disclose that information. And of course, it would go the other way as well. If you were obliged to share all this information with insurers, then there's all sorts of privacy and care issues in the other direction. And we mentioned polygenic risk scores. So polygenic risk scores, in essence, are a summary measure of how likely you are from a genetic perspective to develop a particular disease. And these are the subject of a lot of interest at the moment. There's a lot of people in the private sector who are developing these scores. They're keen to sell these scores to the NHS and to other health systems. And the interesting thing about polygenic risk scores for screening people for disease is that they almost certainly do add a little bit of extra information that you might not get from traditional risk predictors of future disease, like your age, your sex, whether you smoke, whether you're a little bit overweight, whether you have a family history of a particular disease. And the issue really is whether it would be worth it to spend a lot of money collecting these polygenic risk scores on potentially every adult in society or every adult and child in society, just so that we could very slightly improve how well we screen for some diseases. And this debate has become quite contentious because in some cases, using these data would help us find people who are at very high risk of getting sick. But for most people, it's only going to add a very, very small little incremental benefit to how well we could identify people at risk for disease. And again, that raises questions of equity. Most of these diseases, or most of these scores are available in people only of European ancestry. And it's also potentially taking money away from other aspects or other elements of the healthcare system where we might get more bang for our buck. As a social scientist, in my time in the Center for Personalized Medicine, which is about 2.5 years now, we've been trying to introduce some of these new perspectives outside of biomedicine to understand some of the wider societal implications of personalized medicine. And we've had talks extending to things like education and palliative medicine, as well as in insurance, which are going a little bit beyond the traditional scope of personalized medicine. But some of you will have seen the release today of report from the Chief Scientist's Office looking at the implications of genetic data, genomics beyond healthcare, so genetic data in wider society. All these issues are only going to become much more prominent. And one big event that we're planning to do at some point in this calendar year is a debate on whether we could and should use polygenic risk scores for population level screening. So I'll stop there and happy to answer any questions at the very end. Thank you.
Brilliant, thanks, Parag. And now over to Nikki.
Hi everybody, thank you very much for having us here today. I went for a slightly different tack on the slides. Avoiding the next slide, please issue. I only have a single slide. And I got very frustrated with trying to find the figures that I wanted for this. So I also doodled it out a little bit. So hopefully it's somewhat understandable. So firstly, just to kind of introduce myself, my name is Nikki Whiffen. I actually run a research group at the Wellcome Centre for Human Genetics called the Computational Rare Disease Genomics Group. I'm relatively new to that endeavour. I think we've been going 17 months to date. So I'm very new group leader within the centre, and I have a small team of 4 people. And what we try to do is, in a nutshell, to try and find new genetic diagnoses for patients with rare disease. I'm just going to kind of very quickly take you through kind of why I think that matters, what some of the challenges are in personalised medicine, and where we're going towards treatment. So for a patient with a severe rare disease, so if you imagine a child with a developmental disorder, finding the cause of that disease is incredibly valuable both to that patient and also to their wider family. A lot of these patients go through what we call a diagnostic odyssey, which I think the data from Genomics England is this average is around 7 years and tens and tens of clinical appointments. And sometimes getting a genetic diagnosis is actually the first diagnosis they have and the first clue they have to what is actually wrong, and some kind of potential hope that this can go towards treatment, but mainly answers as to why there is something wrong, and it's a lot of comfort to the family. Often it can then be used in the wider family for prenatal screening, or also familial risk prediction. So if that child has a sibling, what is the chance that child is also going to be affected? Or if the family want to have a second child, what is the recurrence risk? So what is the chance of that child also being similarly affected? And for more later onset conditions, this family screening can be very powerful to identify people, say for cardiovascular screening or for interventions. What the genetic diagnosis can also help us sometimes with the prognosis. So to have a look at how the patient might do clinically or how they might respond to certain treatments. And actually with the promise of personalised medicine in the future, there is a huge promise that we might be able to use it to diagnosis to personalised treatment specifically to that patient. One thing to note here, though, is that often these diagnoses are incredibly specific to patients. That's why I've got n equals 1 right in this top corner. And often we've never seen that variant before. And pharmaceutical companies are interested in common diseases where they can make a lot of money out of a single drug. And this is kind of the complete opposite here, where we're looking at potentially designing a treatment to one specific person. But there's also a problem wider than that, is actually in the first place, and this is kind of what my research team centers around, is finding that genetic variant in the first place. And most of the time, we've never seen this variant before. And in the sea of the thousands of variants that we see when we sequence an individual's genome, how do we figure out which one of those is the variant that's actually leading to disease? And sometimes this is just a single base change in the DNA, and it's kind of a needle in a haystack, or as my husband likes to say, a needle in a stack full of needles, because they all look the same, and it can be very difficult to distinguish between them. So we have this kind of huge n=1 problem, and how do we kind of begin to design treatments for individual patients? And there's kind of a couple of areas I'm going to mention where we've got some promise for this at the moment. One is drug repurposing. So if we find that the mutation of the variant in the patient, it hits a particular gene, or maybe we've already got a drug that targets that gene, then this can be a really powerful approach to finding these individualized treatments. Or secondly, there is a technology called antisense oligonucleotides, or ASOs, where we can kind of develop the broad technology, but actually we can design specific ASOs that target specific mutations. So there's lots of work in the rare disease field at kind of developing these ASO therapies. And there's some kind of big companies and not-for-profits that are actually trying to make a difference to a lot of patients' lives at the moment by actively trying to design ASOs for their specific variants. And in the future, actually, I'm sure you've all heard about CRISPR, the kind of new genome editing technology. So in the future, we may well get to the stage where we can edit single DNA changes, although we've still got quite a long way to go in that field. So just kind of flipping now to my role within the CPM. So one of the things that I've been doing is setting up a blog where we kind of post all sorts of different things, and then also arranging events and conferences. And one of the things you can check out on our website is we did a conference last year looking at health disparities, which I think was really, really fascinating, and also with a session on how COVID-19 has been impacting different populations differently. So please go to the website and check that out if you're interested. And then I'm going to stop there and pass it on.
Brilliant, thanks so much. And again, if we can leave questions till the end and go straight to Rachel now. Thanks, Rachel.
As I said, I'm Rachel Horton. I'm a new JRF at the CPM and a clinical training fellow in Annika's research group. And I wanted to start by talking a bit about my research interest, which is what we should consider to be a genomic result. And I feel this is relevant to the work of the Centre for Personalised Medicine, because genomic results form the foundation of so many personalised medicine activities. But unless we've kind of critically appraised what we mean by them and have agreed on what we're talking about, it's hard to advance policy and practice and to have useful debates in this area. And the issue essentially is that if we looked at the genetic code of any person in this meeting, there'd be 4 to 5 million ways in which our DNA was different from what we might view as the standard or reference sequence. And somehow out of all of those millions of variations needs to be distilled the result of that test. Loads of these variations have no known impact on health. Some of them you could infer where our recent ancestors might have lived, or they might be associated with traits that we might have or that perhaps others in our family have. Some will be linked to diseases that might affect us either now or in the future, or perhaps other people in our family now or in the future. But loads of these variations are really heavily context dependent in terms of their medical meaning. So some, for example, might predict conditions that might affect us later on in life. Some might be much more meaningful if we have a family history of the condition they're associated than if we don't. Some might depend on things like our intentions about having children, and if so, what our partner's genetic code is, because we're all carriers for a few rare genetic conditions, and it doesn't cause us any, there's no reason we'd know about it unless our partner happened to be a carrier for the same condition often. Environmental exposures like kind of smoking and that sort of thing might also impact the likelihood that a particular genetic variation we have will actually go on to impact our health. And our knowledge around what these variations mean is evolving all the time. There's a lot we're uncertain of, and a lot that we probably feel more certain of than maybe we we should be. And these things are evolving in unpredictable ways. So to give one example, the genetic factors that might make us more or less vulnerable to being very unwell if we got COVID will have been present in our DNA since conception, but it wasn't until the last kind of year and a bit that they have become potentially medically meaningful. So I'm really interested in sort of when and why particular genetic variations are afforded that status of being a result, and who should be involved in those decisions and how should we decide. I think often, partly I guess because of historical use in investigating very early onset conditions due to a single severe genetic change, there's a sort of assumption that that we know what a genomic result will be when we meet it, and that the issue is working out how exactly to prize that out of all this massive variations. But I think especially with kind of new initiatives like newborn genomic screening and all that sort of thing, that raises so many ethical questions and decisions as to when we're looking at genetic variation, what we should treat as being a needle and what we should treat as being hay. And I think sometimes that context is less represented in the media and things than might be useful as genomic testing transitions, maybe from being used to diagnose and investigate rare conditions to being used in broader contexts. And so I'm really excited to kind of discuss that more and explore that more through the CPM. One of the things which I'm excited to be doing at the moment is running a Doodle competition for people who are working or studying at St Anne's, exploring what people's thoughts are about healthcare data, what it means, what we should be doing with it. And so I'm asking people studying and working in the college to kind of doodle their thoughts and send them in. And I'm really excited to see what that's going to show. So that's one of the things I'm doing with the CPM at the moment.
Great, thank you, Rachel. And last but very much not least is Katherine.
Hi everyone, so yeah, I'm Katherine, and as well as being a new junior research fellow at CPM, I'm also a postdoctoral researcher in the Gorielli group at the MRC Weatherall Institute of Molecular Medicine. And as part of this role, I kind of straddle quite a few different areas of genetics. So my work really focuses on reproductive genetics, population genetics, all under the broad umbrella of clinical genetics. So I'm just going to talk about a couple of the key projects which I'm involved in at the moment, which relate to sort of personalised medicine. And then I'll finish off by talking about some of the initiatives that I've been doing with the centre. And one of the main studies that our research group has been working on recently is called the PregCare study. And what this study does is focuses on a group of mutations known as de novo mutations. And these are mutations which are present in a child, but aren't apparently present in mum or dad. So they're basically new mutations in a generation. And these can be a good source of genomic diversity, but in some cases, they can cause quite severe developmental disorders. And in fact, I think it's about 1 in 300 live births with severe developmental disorders are caused by these de novo mutations. So understanding them, where they come from, that's really important in order for us to understand disease better. So in the PregCare study, what we've done is taken, I think about 65 families who have had a child born with a severe developmental disorder caused by a de novo mutation. And for these families, the parents are thinking about whether or not to have another child. And using very complicated genetic tests, lots of deep next generation sequencing, we've been able to provide every single one of those families with a personalised recurrence risk for how likely it is, if they have another child, will that child be affected by the same mutation and have the same developmental disorder. In the majority of these cases, that recurrence risk is very, very low, and we'd hope that that should, be reassurance that the families can go ahead with another pregnancy and be quite confident. But in some cases, that recurrence risk has been considerably higher. So as I say, we've given all 65 of these families this personalised risk score. And what we're doing now is working with genetic counsellors to follow up with those families and see whether having that risk score has in fact altered or changed whether or not they're thinking about having another child. And hopefully we plan on rolling this out into clinics kind of across the UK, as we think it could be a really valuable tool for kind of genetic testing. So on the more kind of laboratory intensive exploratory work that I do, I'm also studying the origins of these de novo mutations. And in fact, the vast majority of de novo mutations are actually paternal in origin and actually come from the male germline. So they originate within the testes of the father. And then when a child is born, that child has that de novo mutation. And we found that a group of de novo mutations which cause a range of disorders, including achondroplasia, which is one of the most common forms of dwarfism, and another group, or kind of which is part of a group of disorders known as the rhizopathies, that there's a process happening in the male testes which is very similar to clonal expansion in cancers, whereby if you get a certain mutation within particular genes, this gives those cells expressing that mutation a selective advantage. So they grow better or they survive better, leading to clonal expansion of these kind of mutant cells. What this means is that as a dad or as a male gets older, it's more likely, if he goes on to father a child, that the sperm that's used to fertilize the egg will be one of these mutant sperms. And so what we find is that these disorders are very heavily linked to the paternal age. So it's known as the paternal age effect. So in terms of then population health, what this means is it could have real implications for public health advice, because we can see that advanced paternal age is very important in the rate of de novo mutations. So it might alter the way that we discuss kind of when people should be having children, but more importantly, because we understand there are many factors which govern when someone feels ready to have a child. For, say, older people who are older, whether or not we can offer them non-invasive prenatal testing and how we stratify the resources that we have. So that's a bit more about my work, and just a couple of things then that I've been doing for the CPM since I started this role in September. So as Annika mentioned earlier, probably my key piece of work that I've been doing has been to create this vlog series, which has been a flash interview series where I've talked to, I think, 9 different people now involved in personalised medicine in one way or another, talking about their career, what personalised medicine means to them, and what they think the future holds for personalised medicine. So there's been quite a broad range of people. I've talked to clinicians such as Andrew Wilkie, sociologists like Nina Hallowell, but I've also talked to people in industry about how academia and industry can work together for personalised medicine. I've talked to people involved in kind of more large-scale genetic screening, and also people involved in personalised therapies. So I found it absolutely fascinating. I've learned so much from listening to what these people think about personalised medicine. So if you're interested, they're being released weekly on the website and on Twitter. So I would love it if you could listen. And then the other thing that I've been doing is working quite closely with the Student Society, which is linked to the CPM, to set up a scientific careers mentoring scheme where students, so undergraduates and postgraduates, who are interested in personalised medicine are being paired up with people kind of further into their career, generally early career researchers, so postdocs, where they can work together and kind of act as mentee and mentor to help them achieve their goals, get more interested in personalised medicine, if they research opportunities. I've acted as a mentor before in the past, and it's been really valuable. And I think that this is a great scheme for kind of helping people, keep staying involved with personalised medicine. So that's me. I'll hand you back to Annika.
Great, thank you, Katherine. So really, I just want to round off those brilliant short summaries of what the JRF's up to by sort of highlighting that a lot of the discourse about technological developments, particularly in genetics and genomics, are very deterministic. So they imagine that we are going to easily improve medicine as a result of that technology, and that knowledge is power, and that people are empowered, therefore, by finding out about their genetic code, perhaps through direct-to-consumer testing or through screening of whole populations at birth, but that also misses a whole discourse where the sort of real-life complexities are missed. And I hope that the talks earlier give you a bit of an insight as to where those complexities might lie. And as Porrick says, just today we've had the launch of this report, Genomics Beyond Health, which is looking very much at what role, it's starting a conversation about what role genomics might play outside of the health sector. And one very good example there is of direct-to-consumer genetics testing, and the 23andMe is a well-known company, but there are lots of companies out there. And we've highlighted in the past that whilst that has lots of promise, it's also very easy to get false positive and false negative results from that, which is something that people don't quite imagine. I think the discourse about the technology is that once we've got those letters of our genetic code, things will be clear. And that's often not the case. So this is my sort of, I could summarize in lots of different ways, but I think just to say that personalizing medicine, whilst it sounds very appealing, is complex, and people have slightly different definitions of what they mean by that. But I think it's safe to say that it's full of imagined futures that are driven more by technology than by a sort of contextualized interpretation, and that the gap between the discourse about the power of big data and genomic predictions and the power to actually change medicine for an individual in an evidence-based way is still quite large, and larger than many people expect, certainly larger than patients that I see in the clinic often expect. So CPM is, we're a lot of us are new to this role, but we've got a really exciting set of activities planned over the next year where we're very much expanding CPM more. We've got more JRFs now, and we hope that will help address and straddle some of these gaps. But I think we'd also really like your input on what you think our focus or priorities might be, and just your reaction on what we've shown you today.